Okay. Let's say I have a text editor, for example, Atom, that I love to use because it has a lot of features that Visual Studio for some reason lacks, or other ones lack. I don't know. Other IDEs lack, like code blocks or something. What can I do to compile my program? Well, I can do CMake files and build files, and build files, pump build files, pump build files on the build file. You know, you can go crazy on build files. I don't like to go crazy. I like to go a little bit simpler. So, I like to use Visual Studio's compiler and use Visual Studio as a debugger. But I like to edit my code in Atom. How do I get it so that way I can compile my code in Visual Studio? Well, there is a command called CL. However, it's not recognized here. That means we have to interface with it. If interface is the word I'm looking for. We need to get that command. How do we get that command from Visual Studio? Well, we can do that via the command line by calling it. However, we have to navigate, yoink, all the way to our Visual Studio folder, which usually looks something like this. If you're using 2013, like I am, it'll be a 12.0. I think if it's 2012, it'll be 11.0. And then you're going to navigate to the VC, and it's going to be here, VC vars all. Now you'll see that when I pay or select all, I think it copied it. There. Now you'll see if when I call VC vars all .bat. Yeah. Okay. Told you to call it. Do you want? Oh, yeah. When I call it, and now say CL, we can see that I get this now, rather than what I got before, which was CL not recognized command. So now I actually have access to Visual Studio's compiler via the CL command. I think there's help too. So there's documentation here. There's also documentation on the MSDN website, which you're going to be looking at that quite a bit if you're going to be using this. So I have my own command prompt that I have set to automatically call that thing so I can get it from here. What you can also do is you can also specify an x86 type of build. So now if I say CL, you'll notice that before it was x64, now it's x86. Just in case I want to build in 32-bit or 64-bit. However, by default, it's going to be 64. You can... Actually, I think it's specified on your machine. If your machine is 64-bit or 32-bit, it will do that stuff. As you can see, if I just call it here and then CL, it'll be... Oh, what? Huh. I have no idea. But you can specify if you want. A lot of times when I've called it, though, it specifies x64. Anyway, so now we have access to our to the command line of Visual Studio. So now we can make a build.bat, and then we can do whatever. You know, you can do your echo off. You can make comments all day if you want. But somewhere in there, you're going to call to I swear I was able to. I guess not. But I'll call this vcvarsal.bat and x64 it. And then I'm going to cl and then put in the parameters for the command line. So how this works is when you call cl and then pass it a file, specifically a CPP file, it will compile that CPP file and create a .exe and a .object file in the same directory that you call the CL. So if you want your own little directory that holds the .exe, you're going to have to create a new one. And then you're going to have to navigate to that build. And then you're going to have to reverse navigate to the file. Right? Because you compile that, which is in this main directory here. And then, but you're in the build directory, and that's where you want to put the exe. So you got to navigate out of the build, and get the thing. So if you wanted to specify an x64 build, you would go like that, if I can type, and then you'd back up more. 2 times, in fact. And you can do a thing, which is push directory and pop directory. So when you push something onto a stack, I'm not going to teach you stacking, pushing, and popping too much, but when you push directory, it's going to push this one, and it's going to navigate to that folder until it pops. And then it's going to go back to the previous one. So we can do that. I'm just gonna and then we're going to run this. And it does all this weird stuff. And then, lo and behold, we got .exe, which is, of course, got wonderful magicness going around in it. So we're going to go here. We're going to go to build 64 and run the .exe. It closes too fast, so we're going to pause the program. lib.h and system pause it. Okay. So now we're gonna cd and then we're gonna build, because remember we didn't push the thing, and now we can do source.exe and success. Yay. So now I can show you in here if you want to. Yoink, yoink, yoink. Bunk. Success. You have successfully built your command line. And now you can personalize it however you want. such as an atom, you do a .atom build if you have the build thing going. Bam. That's fine, because that's escaped. Okay, so, and now I can just go ahead and press F6, and now I have all this. But you're probably not liking all that weird stuff that's happening. Go away. Go away. Okay, so to add compiler switches, which I guess I can show you. If you go to yoink MSDN, and I look at it quite a bit, so if you navigate to the compiler options listed alphabetically and wait for MSDN to load, because it takes a while, because MSDN is always slow now. Voice crack. You have all these compiler switches that you can use on your thingamabobber, on your build for your compiler. Things like ZI generates debugging information, which is used for if you want to use Visual Studio as a debugger. For example, ZI, and you can use either the dash or the forward slash. I'm a dasher. That's going to generate a PDB file. And so if we want to, for example, do a go to Visual Studio, and using this little thing, if you have the CL thing, you most likely have the devenv, and you can specify the .exe, and it will open Visual Studio and bring you to the project. If you press F10, it'll bring you to the first line of the entry point, which is your main. Got all this, print success, pauses it, exit, whoops, and bingo, you're done. Okay, perfect. And then you'll be able to save your solution. I accidentally changed the CPP file in there, so that's why it asked me to save the CPP file. Didn't want to do that. If you don't, for example, let's look at the documentation. I don't like how when you build it, you get all this, everything. You get, this is who made this compiler, this is who didn't. So we can look through here, and we could try and look through everything to see specific things we want to keep, get rid of, implement. I want to get rid of the flagging thing. It just happens to be no logo. So if I slap on the no logo, bam, it will just say the specific CPP file it is implementing. Ding. Okay. So if you want to pull these out, make it cleaner, a lot of times you'll have a lot of compiler switches. So you can do set compiler flags equals, the equals has to touch this, or I believe, yeah, it has to touch the compiler flag, so it can't be like this. And then I believe these have to touch too. Unlike your food that you don't like to touch, these have to touch. Sorry. And then this, just like an include or a define in CPP, will directly replace wherever you use the double parenthesis, or not parenthesis, sorry, percent sign, not sure what it's called, with these. So build it again, bam, great. If you want to specify link I think you can do it like this too. You can put the now your linker things inside of here, so you can do export stuff like specific functions or pointer functions, like game update or something. I don't use a lot of the linker stuff, to be honest. Even when static linking, you don't use a lot of linker. In fact, I don't think you do use a couple linker stuff, and I can get to that in some other point, but this is severely helpful. And they have a help thing, so I just showed you the help, but earlier, but that's how you do it. Let's say that you want to, in fact, you have multiple CPP files, and you're interfacing them with a .h file. So let's say include something .cpp. Perfect naming protocol. And then you create a file something.cpp, and you have something here where it's like void and hello world, and you're doing your stuff, and you have a sorry, I meant an H file, something.h, and this does exactly what this does, but you have your something.h, and I don't know, maybe you're a regular C++ programmer and you create signatures, or I'm trying to think of what they actually call it. They call them prototypes. But now you want to build this, and you want to call hello world. You're gonna get a linking error, and this is probably gonna scare you. But don't worry, it's pretty easy actually. What you do is from here, after you do the main one, you always have the your main CPP, I believe. I always put the CPP, the entry point, the one with the entry point, the main, int main, in the front. And so, secondly, you just point it to your next CPP, something.cpp. That will compile something.cpp, and then it will compile source.cpp, and it will implement the binaries from something.cpp to source.cpp. So now when I run it, we're going to get that error because I'm great and forgot to do that. And bam. So now, if I go here and still do source.exe, because that's the one it's going to make, so you can see there's a something.obj. Oopsies. We still have success. And if I want to fix this, because that's probably kind of annoying people, it's annoying me, bam. You can see it's working. That's fantastic. And that's a basic rundown. If you want to do like a scratch pad, I can show you later in another video how to do external libraries, so linking with other libraries. I'm probably going to use GLFW as an example, and probably just as a build-on example with glue or something of that sort.